started. Let's see how the volume is. Can you hear me go well enough in the back? Sounds okay? Okay, very good. Happy Earth Day.
Happy Earth Day.
This event today was started in 1970, and it's basically about paying attention to our natural resources and a few other things, making sure that we recognize they're important and that we take care of them. The oxygen there says that we have to have air to breathe, and we want it to be clean air. And the water thing says we want enough water to drink, and we want it to be clean water, and we really hope that we have enough of it for a long time. And that's the topic tonight. I want to talk about water for Texas. Excuse me, I'll sit down. So where do we get it? What's it used for? How much do we have? And will it be enough? That's the big question. If you start off with the fact that we have two big sources of water, surface water, which is basically river water, most of it comes to us through lakes, and then we have groundwater. You can see Austin, I've got a little star where Austin is. We're in the lower Colorado River, and we're over here on the Edwards Aquifer, and we have the Trinity Aquifer on either side of us. So that's the groundwater in Texas, and those are the rivers, and those are the two places where we get the vast majority of the water we use. I want to start off by making sure that you're going to see a lot of numbers tonight. And we're going to talk about water, and the way you measure water is with acre feet. And that's basically a football field 1 foot deep, or another way to look at it is it's half of an Olympic swimming pool. It's 326,000 gallons, and it's a lot of water. That's 1 acre foot. Excuse me. And we're going to be talking about thousands and millions of acre foot tonight. Here's a chart that shows you the water consumption. Maddie? Oh, no, I can't use it on my computer. You're gonna have to do the best you can. This is water consumption in Texas, and you can see it's remarkably constant over a 2-decade period of time. The bottom bar is for irrigation, and that's basically raising crops. It's, raising milo and corn and sorghum and rice and cotton and things like that. So irrigation water in this chart is for crops. The red bars are municipal. That's the water that goes to cities. Some of that is also used for irrigation. People water their yards. That's irrigation, but that's considered a part of municipal. We also use water for manufacturing. That's the middle yellow bar. And we have to use some water to generate our electricity. So that's the little top kind of orange bar. But the thing about this is it's just remarkably constant. The one that varies, as you'll see, is irrigation. And here's the split between groundwater and surface water. Groundwater's on the bottom and surface water's on top, and it's roundly 60-40 between groundwater and surface water. And here's a chart that shows each of those two and where we get the water from. On groundwater, it's about 60% of what we use, and 3/4 of that goes for irrigation. So most of the irrigation that we're familiar with comes from pumping groundwater and sprayed on crops. Municipal is less than 20% of groundwater. The surface water is half municipal, or roundly half, but irrigation is still 1/3. And so if you combine the irrigation sources, irrigation is about twice as much we use water to irrigate crops for as we do to provide for us in the cities for the water that we use. Here is a chart that shows you two things. One of them is a rainfall chart, and the other is lakes. And this is something you already know, but if you live over here in Beaumont in southeast Texas, you get 55 inches of water rainfall a year. on average. If you live out in West Texas or Panhandle, you get between 10 and 15. So there's a huge difference there. We're about halfway in between with about 35 inches here in Austin. And as you would expect, based on the rainfall chart, the vast majority of the lakes are in East Texas because that's where the water is. There are a few notable lakes that are not in East Texas. We have a couple big ones on the Rio Grande. We'll talk about those. And then we've got some smaller lakes that, for example, Twin Buttes and a couple of others are on the Concho River by San Angelo. And then if you go all the way up in the Panhandle on the Canadian River, you've got Lake Meredith, but those are fairly small. And again, the vast majority of the lakes are in East Texas. We're here in Austin, and Buchanan and Travis are our two big lakes. We'll talk more about those as we go on. Now I want to kind of go around the state briefly and talk about the different parts of the state with respect to water. If you live in the Panhandle, you know about the Ogallala Aquifer, because that's the place where the vast majority of the water in the Panhandle comes from. You can see the picture of it over here. It starts in Texas, and it goes all the way through the Great Plains, all the way up to South Dakota. The colors are the thickness of the aquifer. And in Texas, it's maybe 30 feet to 200 feet thick. And if you go up into Nebraska, you can find the Ogallala aquifer as thick as 1,000 feet. So they've got a huge amount of groundwater further north, and we have had a fair amount here in Texas as well, but we're using it at a rapid clip. And that's what this chart over here shows. The colors show you how much depletion there has been in the Ogallala aquifer. And if you're down in Texas, it's really between 50 and 100 feet maybe that has already been depleted. There's plenty of water up north, but you can see all through Texas, Oklahoma, Kansas, we've been using a lot of that aquifer. There is still some left. This aquifer is extremely slow to recharge. And right now we're pumping about 10 times as much as is naturally going into it. So the aquifer is gradually drying up, and already the water level is dropping in Texas. Some of the wells have gone dry. It's gotten more expensive to pump because you have to pump from a deeper depth to bring it up. Some farmers are switching crops and converting to dry land. And the best estimates that I could find would suggest that we have probably 25 to 50 years left in the Texas Panhandle for the Ogallala aquifer. And after that, there's no more irrigation water in the Panhandle. This is what I thought this is an interesting chart. This is a Google Earth chart. And there's Lubbock and there's Amarillo. And you see those green streaks on top. If you can see them close enough, those are little circles. And each circle is 1 mile in diameter. And the reason that it's like that is when we laid out that land to sell it or give it away to give the land grants, we made them into 1 mile squares, 1 mile on each side. Call that a section. It's 640 acres, and that's what people are raising crops on. So you drill a hole in the middle of your section, and you put a half-mile irrigation arm on it, and you can irrigate your whole circle of your 1 mile circle, and that's what all those little circles are. So you can see where the aquifer is the greatest by the circles above Amarillo and above Lubbock. There are other areas where there's nothing under there, and so there's no irrigation going on. When you go down to the Rio Grande, that's another interesting story. The Rio Grande, of course, is a huge river, and it originates actually all the way up in Colorado. But lately, because we've built a dam called Elephant Butte just above El Paso in New Mexico, very little, if any, of the Rio Grande water makes it past Elephant Butte. It gets used for irrigation out of that lake. Some of it actually comes down into the Texas farmers south of El Paso. But the flowing water, not much of it, makes it past Elephant Butte. And yet, down in the lower Rio Grande, there's a lot of irrigation on both sides of the border that we use, and that water, the vast majority of the water that reaches the lower Rio Grande comes from the Conchos River in Mexico. It comes from the mountains and comes down and it meets the Rio Grande at Presidio. And so that's the Concho River. We have had a treaty between the United States and Mexico since 1944 that each country has promised the other one that they will allow a certain amount of water. And we have always met the water that we need to give to, for example, Juarez out of our portion of the Rio Grande River. But unfortunately, Mexico has been much more reluctant to release their share of our water from the Concho River. And as of right now, there are 5-year plans for delivering this water. And as of right now, Mexico has only delivered 30% of the water that they should have, and we're in year 4 or 5. And as a result, we're really short on water down here in the lower Rio Grande Valley. And as a matter of fact, there was a sugar mill that existed in Santa Rosa, Texas, down in the valley for a long time. That sugar mill shut down 2 months ago because there simply wasn't enough sugar cane being grown because they didn't have enough water to do it. So that's a big issue on the Rio Grande. We do have 2 big lakes on the Rio Grande. We've got Amistad, which is around Del Rio, and then we've got Falcon, which is further down. And this is a chart that shows you the volume in those lakes. And you can see since we built them in the 1990s, they've been way up and then way down during the droughts, and then they fill back up again and they go back down. And this is wiggled up and down. Today, there's the levels today. I guess that's Amistad is at 13%, and Falcon is 28%. So they're very low, and unfortunately, there's no, unless some unusual weather event happens, there's not much chance that they're going to get any water anytime soon. So it's an issue with the lower Rio Grande Valley. We manage the water in 2 completely different ways. The rivers are managed by river authorities, most of them. They're kind of a quasi-private government entity who manages the rivers. There's one for the majority of the rivers. We're in the Colorado River. The other rivers have some. There are a few other entities that manage the surface water, but it's mostly rivers. As far as groundwater, several years ago, we set up groundwater conservation districts to manage the groundwater, and that is largely on a county-by-county basis. There are some areas where several counties have gathered together to do it, but for the most part, we manage groundwater through county conservation districts. Here's our Colorado River. We've got the upper Colorado River and the lower Colorado River. We're down here about halfway through the LCRA. The upper Colorado River is really quite a bit different than the lower. It doesn't really operate or manage any dams. There are 3 lakes up there that are important: Spence, Fisher, and Twin Buttes, all around San Angelo. And each one of those lakes is independently managed by people specifically for that lake. The upper Colorado River does provide financial and administrative support, but those dams are managed by each individual lake. And it's been so dry that they almost all were dry in 2011, and they're almost dry right now. Spence has got 3% in it as we speak. O.C. Fisher, I think, is like 17%, and Twin Buttes is 15%. So these 3 lakes are all very low right now. And what that means for us is we cannot rely on the upper Colorado River to provide any water during droughts for us down in the lower Colorado River. It just isn't there. So let's take a look at LCRA and Austin. Austin gets its water from LCRA. And here we're talking about the Highland Lakes. There are, I believe, 6 of them. The biggest 2, as you know, are Lake Buchanan and Lake Travis. And those are our 2 primary storage lakes. Those are the 2 big lakes that we rely on for storing and using the water downstream. All of the other 4 lakes are constant level lakes. They're much smaller, and they are not counted as we plan for water supply. They're there primarily for recreational purposes and aren't really counted on as a water supply, even though we draw out of them. We draw out of Lake Austin to supply Austin, but the water comes from Travis and Buchanan. Here's another chart just to look at the lakes a little differently. This is Lake Buchanan. It gets its water from the Colorado River, from Pecan Bayou, and the San Saba River runs in. So that's the main supply to Buchanan. Inks Lake's a little one. LBJ is also a fairly small lake, although it has the Llano River that enters into it as well as Sandy Creek. And then you come down and we've got Lake Marble Falls, and we've got Lake Travis, which gets the Peternatas River, and then below that's Lake Austin, and there are no other big lakes between Austin and the coast. This is a chart that shows you the level in these lakes since they first filled. They were built back in the 30s. We filled them up, and we've got about 2 million acre feet of water when the lakes are full. On average, it's about 1.6. That's the chart that's going across there. And you can see what's happened over the years. We'll get a big rain or a hurricane or something like that. We'll come through and it'll fill the lakes up. And then we'll run into a drought and the lake levels will go down. There's the drought of the 50s that everybody remembers and talks about. And then it rained again and the lake filled back up. And then we had another drought in the 85 and it filled way back up again. In about 2011 or thereabouts, we had a several-year drought, and that's now the drought of record. Between 2011 and about 2015 is the lowest level that our 2 big lakes have ever been at. So that's what we count as a drought of record. And guess what? The lakes fill back up, but they're back down here again. So that's where we are today. And you can see that we're nearly as low as we've been going all the way back to the beginning. So we need a big rain in our Highland Lakes. Here's the LCRA history of water supply, and it's by the users. And again, municipal for 2 decades is relatively constant. That's kind of surprising, and we'll look at that in a minute. But that's municipal. The thing that wiggles is the irrigation water. And you can see that when you get a drought like 2011 and 2013 and 14, we really started shutting back on how much water we're sending downstream to the rice farmers. And then it rains again, and we've got water that we can supply, and this ends in 2022, and sure enough, we've had a drought in 23 and 24, so there was no agricultural water sent in 2023, and we announced, I think, maybe last week or week before, that there will be none sent down this year either. So the agricultural water is going down substantially. There are a couple of other uses of water on the Colorado River. You can see industrials in green, and then we've got this environmental use that we're obligated to send down to the San Antonio Bay. And that's what this next chart shows you. This is a little busy, but I think it's an interesting story, so let me try to go through it. This is a map of the bay. There's Matagorda Bay. There's Lavaca Bay. I think, let's see, yeah, that's Port Lavaca right there. You recognize that. And this is the Colorado River coming down. And before about 1900, there was a huge log jam in the lower Colorado that was there for years and years. And every time it rained, it caused big flooding. So we had huge flooding. And Matagorda Bay was completely open. There was nothing splitting east from the main Matagorda Bay at that time. In 1929, there was a huge flood, and it broke loose that log jam, and all of the logs and all of the accumulated silt and everything else flowed down the Colorado River and into the bay, and the silt settled out, and it actually caused a land bridge to exist from the mainland over here to Matagorda Peninsula and split Matagorda Bay in two. And in 1935, we actually dredged a channel to allow the Colorado River to flow through that land bridge and into the Gulf of Mexico. But what we learned was that was not good for marine life in Matagorda Bay. For most fish, oysters, and shrimp, you have to have some fresher water, not pure salty water, particularly for the young species. And so we call them nursery areas. So we need some areas in these bays that get fresh water from the Colorado River. And so we have passed rules that say we must do that. And so we are obligated to send Colorado River water all the way down, and it now goes into, since 1991, we're dumping it into Matagorda Bay. So we're doing what we need to be doing to preserve the fisheries here, and we've done the same thing over in Lavaca Bay. So when you hear about, we're sending water down for the shrimp, we are, and there's a good reason for it. Here is a chart that shows you how we've ended up today with respect to providing irrigation water for the rice farmers and other farmers downstream. We've got a rule that says we'll give them some out of our two big lakes up here as long as the lakes are at least 55% full. And if they are 55% full, which is 1,000,001 acre feet, we can turn loose up to 180,000 acre feet in the spring and another 70,000 in the fall. And then you can see the chart here. The only problem is lately we're less than 55% full, and so that means that there is no water allowed for irrigation coming out of the Highland Lakes. We have just completed a new, it's called a reservoir, but you can think of it as a lake to help the situation. This is Wharton, Texas, and about 15 miles down the Colorado River from Wharton, you can see a little rectangle down here. That's Arbuckle Reservoir. We have just finished building that. It cost $500 million, and it is being filled as we speak, and hopefully if we get some rain, it'll be in use later on this year. It will be a source of water for LCRA to use to supply what we owe the rice farmers and the environmental water for the bay when we have it. So this is it's like a little piece of Lake Travis all the way down the coast that we can help manage. It's fairly big. It's 40,000 acre feet capacity, and that's more water than the sum of Lady Bird Lake, Lake Marble Falls, and Lake Austin all put together. So that's a pretty big lake, 1 mile by 2 miles. And it'll get used and fill back up, and they're estimating that on an average year, it'll be able to supply about 90,000 acre feet for LCRA's commitment to agriculture and to environmental water. Just about a month ago, there was another one of these reservoirs announced. Permit was granted by the Lavaca-Navidad River Authority in February, and what they are planning on doing is building another reservoir down at the end of the Lavaca River, and it will be a private reservoir for a great big industrial facility down there called Formosa Plastics. They've got a huge plant in Point Comfort, there's Port Lavaca. And they're gonna build this reservoir somewhere on the land that they own down there. And it will be about 25% bigger than the Lake Arbuckle. And it will again take excess water that comes down the Lavaca River and also the Navidad through the existing Lake Texana that's located down there. So that's the second big man-made reservoir that we'll have in Texas to help out supplement the lakes, if you want to think about it like that. Okay, let's look at Austin. Same kind of a story. This is the water demand for the city of Austin, and it's been again relatively constant for 2 decades. And you know that in the last 2 decades we've had a very substantial increase in population. So you say, how can we use the same amount of water and have all those extra people? And the reason is because we've been quite successful with our conservation programs on using water. And this is a chart that shows that. This is the number of gallons a day per person. So on average, each one of us in this room used to use 193 gallons of water a day. And you can see that that has gone down. The city started doing some things about it, checking how much you water your yard and a few things like that, telling you when you can water it, when you can. And so as a result of those conservation messages, we've got down as low as 120 gallons a day. And so this progress, 40% reduction in the use per capita, has allowed us to have that growth in population with really only a small addition to the total water that we use. And as far as who uses the water in Austin, it's roughly equal. Single family is the largest. That's us, that's multifamily, and then you've got commercial businesses and things like that. So that's the split on who uses the Austin water. Another way to look at the same thing between the 3 sources, and here you can see lawn watering. So outdoor is basically watering yards, and indoor is for all the things inside that we use water for. It's about 20% for lawn watering and 80% for indoor. So here's a big question: what about climate change? How does that affect it? It is getting warmer, there's no question about that. It's increased between 1 and 2 degrees in the past century. There's a chart that's the average United States temperature, and you can see that it's gone up over that's since 1895, so that's a century and 30 years. This is the maximum temperatures for the United States. Same story, it's gone up. And there's an interesting thing in this chart, and it shows up in all these broad temperature charts, and it also shows up in things like the temperature of the oceans. There was a dip in the 50s and 60s and all the way in the 80s. It was warming up, and then it cooled off for a little while, and then it started warming up again. And the best theory, it's pretty fair now, but the scientists are pretty sure that the reason for that dip was all of the air pollution that we all can remember from the 60s and 70s. Remember the brown smog in the sky and all that stuff? That's primarily aerosols and a bunch of sulfur dioxide that came out of coal plants. So we had pretty bad pollution back in the 70s, and we did something about it. We passed the Clean Air Act, and we made some changes, and we made some big improvements in how much aerosols we have in the air. And that was good because it cleaned the air up, but guess what? It took the aerosols out of the air, which were providing a cooling blanket for the earth, and so now it's started to warm up again. So that's the main theory for how come you have that dip. We still have aerosols in the air, but our use of fossil fuels and increase in carbon dioxide is overwhelming the aerosols, and so we're having the warming that you can see here. A couple of charts in rainfall and droughts. We measure droughts by something called the Palmer dry index. And that's what this plots. And you can see that it's fairly constant. It goes back to 1895, I think, and that's up through almost today. It's a little wetter now than it used to be back then, but not much. It's fairly constant. This is a rainfall chart for the average rainfall for the state of Texas. And I say there's no significant change in the last century or more. So we're about the same as we've always been on rainfall and about the same as we've always been on drought. Heat waves. Guess what? In the 30s, in the Dust Bowl, we really had a lot of heat waves. This is the United States, it's EPA and NOAA numbers, and they measure this. They have the annual heat wave index. So there it is. There's the history of heat waves in the United States up until 2020. And that's the last year that they have a particular number for. But I'm guessing you, like me, can remember last summer. 2023 was an unbelievably unusual year for temperatures. All over the world. It was just remarkable. NASA says 2023 was the hottest year since we started keeping records in 1880. It was only the 5th warmest year in the United States. Some of the scientists have tried to explain that. It's very hard to explain because it's such an unusually high shift. But here's what they're saying. A guy from NASA says, he says it's an exceptionally high sea surface temperature helped by the return of El Nino. And those two things were largely responsible for the record that we have. At the end of the day, humans are heating the planet and El Nino is dancing on our heads. El Nino, of course, is a totally natural cyclic event. A guy from the University of Miami said it's like the whole climate just fast forwarded by 50 or 100 years. That's how strange this looks. And a guy from Woods Hole says this could just end up being natural variability. And so the school is still out among our scientists on why we had such an unusually hot year last year. There are two things that they're pointing to that might have explained at least a part of it. There was a big volcano that happened in the Pacific in January of 22, and we passed some rules a couple of years ago that got the sulfur out of fuel for ships going across the ocean. And so we have pretty much eliminated the aerosols from the sulfur dioxide that comes from burning the fuels in the ships in the ocean. And that is significant enough to make a difference. So we think that maybe those are the only two things we can point to that should have made such a big difference. Long term, there's no question that it's getting warmer. And on the short term, there will be big variations, like with El Nino coming. Now it's gone. Now we're going to have La Nina this year. And so it's back and forth on the short term. This is last summer. And guess why we thought it was so hot? It was focused on Texas. The red is a number of 100 and triple digit days. And, you know, we had the most of it by far. It was hot everywhere, but we understand it more than most people do. This is a chart that demonstrates how unusual last year was. This is a chart that shows the sea surface temperatures. This is the middle of the Pacific. And, you know, it's seasonal. You can see the up and down as we go through a year. And you can see global warming by looking at the temperatures. These are back in the 70s, and then as we come forward in time, and we get up here in the 2020s, the temperature is higher. But look at 2023. It's out of sight off the top. And that's what we That's what we really don't understand very well. But it's there and it's still pretty high. Here's the Atlantic Ocean, the same kind of thing. This is basically the middle Atlantic. And the same story with global warming bringing it up. And there's 2023 and there's 2024. So it's still, right now, the Atlantic is quite a bit higher than it normally is. And that's why a couple of weeks ago, when they came out with the hurricane forecast for this year, two reasons, this is one of them, that they're predicting that this year will be a higher than normal year for hurricanes because of a hot ocean, basically. Here's this Tonga volcano. That's a satellite image. This was the biggest volcano we've had since 1991. And it shot mostly water vapor higher than anything we've ever measured, 36 miles up. And it put an enormous amount of water vapor into the stratosphere, increased it by 15%. And water vapor, by the way, is the biggest greenhouse gas that we have. We focus on carbon dioxide, methane. Water vapor is much more important for global warming and greenhouse gases than the others are. And that's why they're thinking that maybe with that significant amount of water that went way up in the stratosphere, that it might impact the temperature. One scientist says increase the temperature 1.5 degrees centigrade over the coming decade. So that's the reason that we believe this volcano might have been a contributing factor to what we're seeing right now. Time will tell. It's probably going to be hot again this summer, and who knows after that. Okay, let's go into some projections now on water. Let's look at the state first. And really, statewide, it's a lot about irrigation. That's 2/3 of the water we use. So if you want to really cut the water back, we've got to get more efficient with our irrigation. That's the way we do it now for the most part. In a lot of other parts of the world, they do it with drip irrigation. It's obviously more expensive, but it's much more effective. And we're going to have to move from here to here if we want to cut that irrigation water down. And the other thing that people in Texas have talked about for decades, well, we've got all that water over in East Texas, why don't we just build a pipeline and pump it to Austin? We won't have to worry about it anymore. We have fought that battle. Wherever Max Sherman is, he'll tell you all about it. It's been going on forever. And you can see why. This over here are the rivers, and the numbers that I have off to the side are the annual flow for that river. So the Red River flows 3.5 million acre feet. The Sabine-Neches combination is 10.2. Trinity and San Jacinto 7.1. Brazos 6. Colorado 2. Guadalupe, San Antonio 2. Oasis 0.6. And Rio Grande 0.6. So you can see the marked difference between the Sabine River at 10 and the Colorado at 2. And that's why people want to pipe it from the Sabine River over here to West Texas. It is hugely political, and it always will be. And I don't know if it'll ever happen, but that's one of the things that we say is might help us. Here's LCRA's long-range projection. They do this about every 10 years. They really study it, and they update it every year. And this chart that I show here is the latest update. It's, I think, from last year. And so this is what LCRA thinks their water situation is. They've got 600,000 acre feet out of the Colorado River that they can count on as firm supplies. Our usage is down here right now at about, 300,000. And you can see the projection. Business as usual is the green line, and if we don't do anything differently, we're probably good until about 2080 with respect to water from the Colorado River. If we do more conservation, which we intend to do, that'll take us out to 2090. And if we build one of these reservoirs like we've talked about down below, that'll add some more to it. And we can see good water all the way to 2100 with doing either nothing or the things that we ought to be doing. So that's LCRA's long-range forecast. City of Austin has a similar thing. You might guess that it looks kind of like LCRA's since that's where we get the water. But they have a water plan for the next 100 years, and there it is. We're allocated 325,000 acre feet a year. That's that line. We're currently here at about 200, and you can see our growth. This is the baseline, which is business as usual, and it'll get us out to about 2070 or so. And if we do conservation, which we hope to do, we'll be able to make it 2080 and 2090. And that, in order to do that, it takes both increased conservation and at some point alternative supplies. So here is the City of Austin's forecast for what it hopes to do in the next 10 years, I guess, up to 2030. It's looking for an 11% reduction in this gallons per person. We had 119, you and I each used 119 gallons a day this year, and we want that to go down to 106 by 2029. So we're gonna have to look for ways to save water. Some of that is lawn watering. Matter of fact, a big part of it is, you may not like it, but that's easy to do something about. Other things are a little bit more difficult. Here's what the city is talking about. They've got several options. One of them has got to do with yards and irrigation. You know, we have restrictions on when you can water, how often you can water, and that's only going to get more significant. Right now, the city is looking at passing an ordinance that would say that everybody who builds a new house in Austin is only allowed to irrigate half of their yard. They cannot have St. Augustine on the whole thing. They're going to have to do xeriscape or something else. That hasn't been proposed yet, and I'll guarantee you there will be a big stir when it is, but that's probably coming at some point in time. They're also going to require new homes to plant, native species and other plants that don't need water. So basically, it's focused on reducing the amount of yard watering that we do. We'll use smart controllers, and we'll have fancy metering to help that. Maybe the city will even end up deciding when you can water and when you can't. But there will be more restrictions, I believe, in that area. Longer term, there are 3 things that you can do. One of them is called aquifer storage and recovery. And that's pretty simple. We've got the Edwards aquifer below us that we're sucking water out of. Well, you can put it back in and use it like a big tank. And so the idea here is that during those periods when you have excess water, then why don't you take some of that, and instead of letting it just go down the river, why don't you pump it down into your aquifer and use that as a big storage tank like a lake, and then later on when you need it, you can pump it out. That's aquifer storage and recovery. We are going to figure out how to reuse some of our water. Gray water is from your washing machine and your kitchen sink. Wastewater, you know what that is. Storm water and rainwater, we will try to figure out ways that we can use each one of those water sources that we don't now utilize for drinking water. So that's coming. And the other thing is to build these off-channel reservoirs like that Arbuckle that we pointed out a while ago. Those are the longer-term kind of things. San Antonio has already done a lot of this. They've got the aquifer storage and recovery going. They're also on the Edwards aquifer, just like we are. And they've got a well that they can use to either pull water out when they need it, or if they have excess water, they can pump it down back into the aquifer. They've got a capacity of about 200,000 acre feet. It's like a giant underground tank, they already treat the water that they put down. So when they pull it back out again, they don't have to run it back through a treatment plant. It's ready to drink when they bring it out. They get an allocation from the Edwards Aquifer for the groundwater, and when they have more than they need, that's what San Antonio is doing right now. Kerrville has a similar kind of a process. You can also desalinate salt water, and San Antonio is doing some of that right now. If you go a little deeper, you'll reach a brackish water zone, and you can suck water out of that brackish water zone. You can put it through a desalinization plant, like this is San Antonio's desalinization plant. 12 million gallons a day, that's 53,000 houses of water that they're pulling out of salt water and desalinating. So they're doing that today. El Paso is doing that in a pretty big way. Countries in the Middle East are almost all on desalinization. So that's available to us if we need it. It's kind of expensive, it means the price goes up. But if you need to get water, you can get it from salt water. It takes electricity. So here's where I come out as far as conclusions. You start off with what I think is obvious. Water is a precious commodity. Periodic droughts like we're in right now are going to bring challenges, and they're going to bring restrictions, and we'll probably see some of that this summer. Long term, I believe that agricultural water and also lawn irrigation must be reduced in some form or another as we go forward. I do not think there's an imminent crisis, and I think we'll have enough water for a lot of years, but if we're going to do that, we're going to have to do some long-range planning, we're going to have to spend some money, and we're going to have to continually improve our conservation techniques. So, thank you for your interest, and let me try to field any questions. I don't know if anybody's got a microphone. Oswaldo, can you pass the mic around?
I'm gonna walk up and use yours.
Okay, come on.
I guess I can't.
Here comes Oswaldo. Here, bring you. Sit down.
About a decade ago, water bills went up in Austin, maybe because of a drought, and private citizens were starting to put in their own wells with the understanding that whatever's under your property by Texas law, you can draw. Is that correct?
Mostly so. You're right, people have been drilling wells and are using them, but I don't know how much longer that's going to be allowed.
I just wondered how the groundwater conservation control people, how they can monitor that.
It's hard to do in the city. They monitor it very well out in the countryside. If you've got a farm and you want to drill a well, you've got to go down to the district and they're going to tell you whether you can do it or not. Now the days of just being able to drill a well and pump water, or maybe the right word is limited. That's my opinion. I don't think we're going to be able to do that forever.
Jim,
Yeah.
I don't know anything about this, so this is an ignorant type question, but when Texas did all this drilling for oil wells, did they go below the water table? And did it have any effect on the water table of Texas?
Yes and no. When you drill an oil well really, really fast, an oil well might be 12, 15,000 feet deep these days. Well, by the time you get to I think it's 600 feet here in Austin. But by the time before you get to 1,000 feet, you're hitting groundwater. All oil wells go straight through groundwater and go all the way down really deep. And they have a lot of controls about how they need to protect the groundwater, and they do a very good job of it. I'm sure there have been some instances where some oil wells have leaked, but it's pretty rare. So the answer is they drill through groundwater and it doesn't bother the groundwater.
What has been the impact of fracking
The impact of fracking, which is, for drilling oil wells and making oil wells produce, as far as the impact on groundwater is virtually zero. Again, because you're not doing the fracking. You're doing the fracking 12,000 feet underground, and the groundwater is at 500 feet. So you're not even anywhere close to the groundwater when you're doing the fracking way down there in the shale formations.
My understanding was that fracking required a lot of water.
Oh, well, it does require water for the fracking process. That, it doesn't affect the groundwater, but it does require a lot of water for the fracking process. And that is a current issue, and there is a lot of work to try to figure out how to reuse that, but the use of the groundwater for fracking is there and significant.
The LCRA continues to permit the development of exurbs, suburbs that are stretching 50, 60 miles now out of Austin, and following the traditional pattern of small yard and grass and the whole thing. People who live in those counties, Burnett and Llano County, are wondering why the LCRA doesn't put some limits on that. Do you have any idea?
I don't. You're right in your observation.
About 10 years ago, I heard a presentation by one of the senior officials of the state on a long-range water plan. And they unveiled a 50-year, $52 billion plan, most of which was taking brackish water, which is apparently available in substantial quantities, and desalinization of the brackish water, which is much less expensive than seawater. I wonder if anything is being done with that plan.
I don't know that, I'm not aware of anything specific on a statewide scale. El Paso has done that within the past 10 years, so they're doing it themselves. I know San Antonio, as I pointed out, does it. But it's fairly expensive compared to just, sucking it out of the river. And so not many people are doing it until they're forced to. And then it's a relatively easy solution because most places have brackish water down there somewhere that you can access if you need it. And again, the technology to clean that water up is easily known. There's no question about that. It's just a matter of the money to buy the facilities and pay for the electricity to do it.
Jim, I just read an article that talked about California had 2 major storms this year.
Yes.
And they nicknamed them oceanic storms, where so much water comes in. And they say they turned around their drought in California. Have you heard that?
Yeah, they turned around the drought for about a year. And that's only in Northern California, because when they're talking about the northern part of the state. LA and San Diego and the southern part gets a lot of their water from the other Colorado River, and it goes through Lake Mead and Lake Powell. Those are both very low. They still have a real issue. They didn't get helped. So the news media stuff that we saw about California filled up Lake Mojave, not Mojave, some lake that they've got been dry. They filled it up, but it'll be gone in a year or two again. They just had a lucky year with a lot of rain.
You need a little luck. Jim, I'm always hearing our rain doesn't come in the right places. Would you pull up a map and say, where does the rain have to come, so we can pray that it falls in the right place over
We need rain right there for the Colorado River. And that's, if you think about think about San Angelo. We need San Angelo to get a whole lot of rain, enough so that their lakes fill up, and it's got enough to spill down to us. And it's also up around Buchanan and between Buchanan and Travis. So that's the watershed for the Colorado River. And that's where we need the rain to go. Unfortunately, in the last year or so, they haven't been getting that much. It's been coming to Austin and further south, and so it needs to go up above. I wish I had some data to show it, but you probably all remember. You can get buckets full of water in either really strong spring rains or the aftermath of hurricanes. And whenever those happen, you can fill up Lake Travis in one day's time if you get a tropical storm that comes up in the right spot. And that's happened on several occasions in the past. It'll probably happen again, but who knows when. I see a question back there.
I've read recently that Georgetown will run out of water in 2030. You know anything about that?
Georgetown is in the Brazos River Authority. They get some water out of San Gabriel that goes through there. I haven't seen the Georgetown. If they're gonna run out of water, I don't know where they get it from. But
Well, what I know is our son's the city manager in Georgetown. And there's some sense about, when Lake Georgetown was built in 1970, Georgetown was 5,000 people. And they had 76,000 acre feet of water. They said, we'll never need this much water. So they shared it with Round Rock. All right? And today, our son and his staff is looking to East Texas to buy water.
yeah,
And it's gonna cost a lot of money. And the residents are not gonna like it, but if they want water to flush their toilets and drink, they're gonna pay for it.
they're gonna have to. That's
So, there is a sense about it's not gonna run out of water, but the cost of water in Georgetown is getting ready to be high. It's gonna be high in Leander.
Yeah.
I mean, it's just it's a serious problem.
It's gonna be high everywhere at some point in time because we're gonna have to do this
And,
thing to
and
get it.
unfortunately, a lot of the surface water that's in East Texas, the water rights have been bought by hedge funds. So you know what happens there.
I used to live in East Texas, and they'll get outvoted one day by the whole state. But if you live in East Texas, your attitude is, hey, you guys, if you want to develop stuff, you bring it over here to us, and you build your plants and your factories and all your jobs, and you put them in East Texas, and we'll give them our water. We're not gonna let you build Samsungs and all that stuff up there in Austin and take our water to do that. That's their attitude in East Texas, but they don't have the majority of the votes, so they'll lose one day.
But the brackish water that they are using for desalination, is there a limit to that, or how does that get replenished?
There's a lot of brackish water. It's just huge aquifers of it, and I haven't seen the specifics, but I can't imagine there's any issue. There's just a lot of brackish water.
So it doesn't get replenished, it's just.
Oh, it doesn't, not near as much as the surface water does.
This big plant that they're building in Taylor, is it Samsung? I don't remember.
Yeah.
Okay. Where are they gonna get their water? Because I read where they need a lot of water over there.
They're gonna get groundwater there in the Carrizo Wilcox aquifer, and that's a pretty good aquifer, and they plan to, just drill wells and pump it out of the ground for them.
There's been something in the press recently about the revival of cloud seeding. Have you read or do we have an opinion on cloud seeding?
Cloud seeding, y'all know what cloud seeding is, it's when you fly an airplane up and you sprinkle something out in the clouds and it causes it to rain. And people have been trying to do that for, I don't know, 20 or 30 years. And I think occasionally they've actually had some success. And we're talking about it again, we're talking about everything that you can imagine, and some of it might even work. I don't personally put much stock in cloud seeding making a big difference, but that's just my opinion.
Could I make a comment about cloud seeding?
Max has got something.
I've lived with this issue for most of my life, but cloud seeding will get some people killed because if you seed the clouds and you get the water there and I don't get it down here, the ranchers in the Texas Panhandle who don't get water are going to kill the people who cloud seed. And that is not just a prediction, it has happened.
That's what the East Texans are gonna do when they pipe it over to Georgetown. Okay, thank you for coming.